Why do we shiver when it's cold? In this video, we'll talk about how our body uses our muscles to maintain a core body temperature. That process is called thermoregulation, the regulation of body temperature. So in order to do that, I'll first give you guys an overview of how thermoregulation works. Next, we'll talk about how our bodies respond to hot temperatures before finally talking about how our bodies respond to cold temperatures. So first, if we have this gentleman right here, who doesn't look very impressed, and he's holding his hand up one day and notices it's really hot outside. That looks really hot. So the skin on his hand and his arm, the rest of his body, will perceive that it's really warm. And in doing so, this will create a neuronal signal, a signal that's sent across neurons up into the brain. And the part of the brain that perceives that it's really warm outside has a specific name. It's called the hypothalamus. The hypothalamus. And in fact, we split up the hypothalamus into two different parts to respond to two different types of temperature. There's the anterior hypothalamus, which just means the front of the hypothalamus, and then there's also the posterior hypothalamus, and that's just the back of the hypothalamus. But which one responds to what kind of temperature? Well, the way I remember it is that if it's hot outside, we like to use the front of our hypothalamus, or the anterior part of our hypothalamus, to respond to temperatures that make it feel like we're on fire. So if we're on fire, we're going to use the front of our hypothalamus to respond. Well, what if it's cold? In those situations, we'll use the posterior part, or the back of our hypothalamus, to respond to climates that make us say, burp. So we use the back of our hypothalamus. Our brain knows that it's really hot outside. Well, then it sends back a signal to our bodies telling it to respond to maintain our core body temperature. And of all things to take point from here and act, it's going to be muscles in our body that will do something to make sure we can maintain our core body temperature. That'll involve smooth muscle, and when it's cold, we also use skeletal muscle to respond to changing temperature. So how does that work? Let's take a look. When we're in a hot or a cold environment, how do muscle help us respond here? Well, the way to talk about this is to go through the two main types of muscle that'll act here. First, there's smooth muscle. Specifically, it's smooth muscle that lines our arterioles. Now, arterioles are just smaller versions of our arteries, arterioles. The other type of muscle that functions here is called skeletal muscle. And that's the type of muscle that works in your biceps, your triceps. All right, now let's answer this question here. Why do you think arterioles have anything to do with temperature? I mean, how does that change whether we have a lot of heat in our body or not? Well, the way that works is that if you take a look at a blood vessel, and I'll just draw a small one right here, it's got a bunch of red blood cells and white blood cells and proteins and whatnot. All of this is just kind of running around through the bloodstream. And the way it does that is just kind of in a random sort of motion or manner. It's never directly forward, but it just kind of bumps around like that and moves this way. So overall, you've got a general movement in the forward direction, but you kind of are bumping around to do this. And the interesting thing is this movement here, this momentum that your red blood cells, white blood cells, or whatever you have in your bloodstream make, that's energy. So we have a ton of energy in our bloodstream. And energy is just another form of heat. So if we are in a hot environment, we want to get rid of this heat. So we're going to put more heat to our most superficial or the most external parts of our body, our skin. So the more blood flow we get to our skin, the more heat we can have leave our bodies. And that's how we get to regulate our temperature. So let's talk about it here. When it's hot, our smooth muscle then is going to relax. And in doing so, the arterioles then are going to become wider or larger. And this process is called vasodilation. Your arterioles are dilating. They're becoming wider. And so the way you could see that happen is that this blood vessel that was about yay big, is now going to become that big in the skin. And so that means that you're going to have a lot more blood flow going in here to the skin. You're going to have tons of red and white blood vessels and protein just kind of merrily tumbling about going like this. That means you're going to have a ton more heat or energy that's present here that can then dissipate and leave. And so that helps you cool off. You're losing all of this energy or this heat that you have by diverting blood flow to your skin. Now, what does skeletal muscle do here? They don't do anything when it's hot. They'll respond in a second, and we'll talk about that when it gets cold. What do smooth muscle do when we're in the cold? Well, you can imagine that if we relaxed when it was hot, it's fair to think that we're going to contract when it's cold. And so this process then in the arterioles is going to be called vasoconstriction. Vasoconstriction, which just means the narrowing of our arterioles. And so if I were to draw that on a diagram right here, you would see that this blood vessel that looked like this in our normal state is now going to turn into something more like that, kind of a pipsqueak, really tiny. So you're going to have red blood cells, white blood cells, and protein just kind of shifting through here like this, but there's not a lot of opportunity to kind of tumble around and be naughty. They just got to go forward. They can only go in one direction because there's not a lot of space here for blood flow. And so in the skin, you're going to have less energy or less heat that's present at this very external or superficial part of your body. The more blood that you have that gets away from the skin, the more that's going to go towards your core. Your core will then have more energy or more heat to help you stay warm when it's cold outside. So that's what your smooth muscle does. What do skeletal muscle do? Well, skeletal muscle will also contract when it's cold. But there's a very different purpose for why that happens. When skeletal muscle contracts, it's going to take ATP, or adenosine tri or 3-phosphate, and break that to make adenosine diphosphate, ADP. So that's 2 phosphates. And we just snapped off a little phosphate group that are made. You actually will produce energy as well. And we call this reaction an exothergy as well. And we call this reaction an exothermic reaction. Exo meaning exiting or the leaving of, thermo or thermic meaning heat or energy. And so we're actually producing energy here by contracting our skeletal muscle. This happens in our core muscle groups that cause more of the heat that's being produced from this reaction to be stored there to help us respond to these cold environments. Now, this isn't such an unusual process that's so foreign to us. The contraction of our core skeletal muscle groups is actually just called shivering. This is the whole reason why we shiver when it's cold, because we need to produce some energy by breaking off some phosphate from this ATP, and that shivering then will help us warm up when we're in the cold. And that's how our muscles help us respond to temperature change.
The Big Cat Public Safety Act has been endorsed by the Fraternal Order of Police, the National Sheriff's Association, and numerous other state and local law enforcement agencies. Because 500-pound carnivores pose a serious and very real threat to first responders, law enforcement officers, entire communities around the country. The photo behind me is not staged. This bill is also endorsed by the Humane Society of the United States and countless other animal welfare organizations, because lions and tigers do not belong in urban apartments or in cages in suburban backyards, and because private citizens simply do not have the resources to care for dangerous animals that are meant to roam over hundreds of square miles. As was stated, this bill is supported by the AZA, not opposed by the Zoological Association of America, the Trade Association for Small Roadside-Type Zoos, because ripping newborn cubs from their mothers moments after their birth to use them as props in photos is already cruel enough. But then, once they're too big to be safely held, brutally killing them is just wrong. Nearly 65,000 Americans have signed a Change.org petition calling for the immediate passage of this bill, because the Netflix series Tiger King showed the world in stark relief how exploitive, dangerous, and inhumane this tiny so-called industry is. This bill should be served by every American because right now taxpayers shoulder the cost of monitoring and regulating private owners. And when big cats are rescued from horrific conditions or simply abandoned by overwhelmed owners, they pay for the care and feeding of these cats. I want to thank the many Republican members of Congress who support this bill, which is co-sponsored by more than half the House. I urge every member to stand with law enforcement community and stand up for those who need our help but cannot ask for that. Please vote for this bill. I yield back.